Hi everyone. Isabel noticed that I made a mistake in the very first question. Nice. So I am putting in a correction video. So if you start the first lesson, I'll put a little note to watch this video first. So what we're going to do is we're going to take the derivative and put it into simplified factored form. Okay, so the calculus is finding the derivative, and then the algebra component is to be able to put it into simplified factored form. So if you look at this question, we see that it's one function of x, power function in this case, being multiplied by another power function of x. So there's a product rule in play there. So to do a product rule, we're going to make our chart first, second, function, derivative. So our first function is x squared plus 1 all cubed, and its derivative using the chain rule would be 3 times x squared plus 1 squared times the inner derivative. So the inner derivative is going to be 2x. And then we can multiply, so we can simplify this by multiplying those two together and get 6x times x squared plus 1 squared. The second function is 2 minus 3x to the fourth. And when we derive it using the chain rule, we're going to get 4 times 2 minus 3x cubed. And then the inner derivative of 2 minus 3x is negative 3. Be careful, the negatives sometimes get people there. And then we can multiply those together, and we'll get negative 12 times 2 minus 3x all cubed. Okay, so we've got these correspond and those correspond. So the product rule says, so here's our derivative. This is the calculus part. Derivative of the first, which is right here, times the second. And when I multiply those two together, I want to put any monomial terms out front. So I've got my 6x, and then any of my binomial power functions in this case. And then the product rule says it's plus the first times the derivative of the second. So I'm going to be multiplying these two together and adding, but I want my monomial term out front, and it happens to be negative. So minus 12, there's my monomial term, times 2 minus 3x cubed times x squared plus 1 cubed. So in that first step, I've now found the derivative, I've done the calculus. Now all of the rest of the steps that come next will be putting it in simplified factored form, which is all algebra. Okay? So the first thing we want to do is look at our two big chunks here and figure out the greatest common factor. So first I'm going to compare 6x and 12, my monomial terms, and the greatest common factor is 6. Then I'm going to compare my x squared plus 1's binomials and choose the one with the smaller exponent. You'll see why in a second. And then I'm going to compare my 2 minus 3x's, and again, part of my greatest common factor will be the one with the smaller exponent. So here's my greatest common factor. This right here is the greatest common factor of these two big terms here. So now I want to divide each of these chunks by the greatest common factor. So if I'm dividing this by the greatest common factor, I would think 6x divided by 6, which gives me x. X squared plus 1 to the power of 2 divided by x squared plus 1 to the power of 2. So I'm dividing the exact same thing. So when you divide something by itself, you get 1. I don't need to show the 1. And now I'm doing 2 minus 3x to the fourth divided by 2 minus 3x to the power of 3. So let's think about that. I'm doing 2 minus 3x to the fourth divided by 2 minus 3x to the third. So here you want to keep the base because I'm dividing powers with the same base, so this is using exponent rules. So I keep the base 2 minus 3x and subtract the exponents. 4 minus 3 is a 1. So when you divide those, you're going to get 2 minus 3x. So now I've divided this first big chunk here by the greatest common factor, and I got x times 2 minus 3x. So now I want to divide this next big green chunk by the greatest common factor. Negative 12 divided by 6 is negative 2. 2 minus 3x all cubed divided by 2 minus 3x all cubed. We're dividing the exact same thing, so we would get 1 again. And then here I'm dividing x squared plus 1 cubed divided by x squared plus 1 squared. So I can use the same idea here, x squared plus 1 cubed divided by x squared plus 1 squared. So I'm dividing powers with the same base, the base being x squared plus 1. So I keep that base x squared plus 1 and subtract the exponents. 3 minus 2 is 1. And now I've common factored. So I've taken the greatest common factor and divided it by each big chunk to get this part in the brackets. So I'm on my road to simplified factored form because now these two big chunks here we're subtracting. Now everything's multiplying. I've got 6 times x squared plus 1 squared times 2 minus 3x cubed multiplying by this big bracket. But what I want to do then is simplify this bracket and see if it can be factored. Okay? To get the whole thing in simplified factored form. Okay, so if I do that inside here, x times 2 is 2x minus 3x squared minus 2x squared minus 2. And then inside these brackets, I'm going to get, maybe make it round now. So negative 3x squared minus 2x squared is negative 5x squared plus 2x minus 2. So I'm making it look like a trinomial. And then I could see whether that complex trinomial could be factored. If it could, there'd be two terms that multiply to give you positive 10x squared and add to positive 2x. There aren't two such terms, so now it is in simplified factored form, and you're done. Okay, so the mistake I had made in the video that I released was when I did 6x divided by 6, I put 6 there instead of x, which I think gave us a factorable complex trinomial here. So it actually, my mistake made it added another step, but here is the corrected version. Okay, sorry about that. Thanks guys. I'll talk to you later. Bye.